is ecosystems, and we're going to learn about matter and energy in the ecosystem. And then we move on to Unit 3, which is kind of like biomes, or like going deeper into lands of the ecosystems, and then relationships in the ecosystems, and then we'll go straight to problems, right? Because that's where it ends up in. So we're going to take it way back to levels of organization to understand how we end up talking about ecosystems. So what components make up an ecosystem? If this was bio, we would start with an atom, and then from atom we go molecules. Molecules make up parts of cells, which are called what? Parts of organelles. Organelles make up cells. Cells make up tissues. Tissues make organs. Organs make systems. Organism, which is where we start in environmental. But you can never say I didn't go over the other ones, because I did. It's in the video. So what's the definition of an organism? A living thing. A living thing that can breed or produce offspring is called a... Yes, I heard it. Say it. I heard it. No, I heard. Yes. Species. Species that are together, a group of them in one area, make up a what? Like we are species in this classroom, we make up the blank of this classroom. Yes, population. When you take different populations and you put them together in a given area, they make up a what? Community. Good job. All right. Communities. What's happening in this picture, actually, before I even define it? We got a Dalmatian. I threw him in there, like literally. Interactions with what?
With other organisms.
With other organisms and?
Their environment.
And their environment. What parts of the environment?
With abiotic.
Good. Okay. So we're interacting with living and non-living things, and this is a test question, actually. What's the definition of that? Organisms interacting with each other and their non-living components. Nope. Environment is everything that surrounds an organism. It's ecosystem. And this is a test question too. By test question, I mean these two words are part of Unit 1. All parts of Earth that support life. Or all layers of Earth where life exists. Yes. Biosphere. Good job. We're covering in this unit matter through the ecosystem and energy through the ecosystem. And they're similar, and you're going to kind of confuse them, but they're different in one major way, okay? So this is a similarity here. Both are laws in science, which is very rare. What is the law of matter state?
Matter cannot be created or destroyed, only recycled.
I love that word. Matter cannot be created, destroyed, only recycled. Mine says transformed. What else can we say besides recycled and transformed? That describes the same thing happening to matter. Changed. Good. When matter gets changed or recycled or transformed on Earth, it can change quality. So obviously, during the transformation, or maybe not obviously, but during the transformation, a lot of the quality gets diminished. So the usefulness gets lost. So quality is how useful that form of matter is. And if we're going to refer to high quality matter, you're talking about stuff that you can have easy access to. It's very concentrated, and it's usually in the form of what? What state? Solid. Low quality matter will be in the form of what? Gas. It's dispersed, molecules dispersed, hard to extract, but it's there.
What's liquid?
Somewhere in the middle, right? Good question. Somewhere in the middle. Who could describe what is meant by matter is a closed system? Which we kind of already did.
It doesn't leave or enter. It just keeps going around.
Good. Matter doesn't leave or enter Earth. It just cycles, right? Or gets transformed. Because cycles, you think of cycle as a wheel, but matter gets transformed somewhere within that wheel. It's not usually a perfect circle. So everything we learn about matter being cycled or transformed, think about the starting point can be anywhere, the end point can be anywhere, but it's going to be changing through states of matter, and it's going to be changing through parts of Earth, such as what? Name the parts of Earth. Parts of Earth. Name me the 3 major parts of Earth. Hydrosphere.
Biosphere.
Well, that's parts of Earth. So biosphere would represent the parts of Earth where life exists. So we've got hydrosphere, atmosphere, geosphere. 3 parts of Earth. Inside those parts, you have a lot of other parts, right? And then living things. So matter is going to travel through all parts of Earth, or most parts of Earth, and living things. And we're going to learn about that, okay? When matter or energy transfers or flows or cycles or whatever is going on, you have some starting point and some end point. We call these systems, right? So matter flows through a system. As it flows, it's going to lose quality, like I mentioned. It's going to come in from somewhere in the environment. It's going to flow through somewhere, and then it's going to go out back into the environment, because that's the law states, right? When something happens that this output here causes an influence back in this direction, some kind of influence, we call that a feedback loop. So when the output, and you've heard of these from bio, comes back into the system and causes some kind of change within the system, it's called a feedback loop. Okay, you have, because you studied them in bio. Don't look at the page, don't look at the notes, just answer this question. If I ask you what the word positive means to you, what's your first instinct?
It's better.
A plus sign and better. So you're going to put a little star and say, positive feedback loop is not necessarily good. When you hear the word negative, what's the first thing that pops into your head? Bad. Negative feedback loop is not necessarily bad. I say for you to write that because that's the first thing you think of, and it's almost usually backwards. I wouldn't say it's backwards though, but in environmental science, positive feedback loops are usually demonstrated as something bad happening in the environment. So what it means is something that's coming out of the system is going to increase that system into the same direction. So I'm gonna give you this first example. As temperatures rise, which is global warming, we have sea ice melting. And with the sea ice melting, you have darker oceans which absorb more heat, which lead to more warming, which lead to more sea ice melting, which lead to more heat, more warming, yes? Positive feedback loop. So that output causes the system to start over in the same direction. So it's kind of like a chain reaction. I'll give you another example. As global warming happens, water temperatures increase, causing evaporation. Water's a greenhouse gas, which leads to warming, which leads to more evaporation, which means more greenhouse gas, yes, positive feedback loop. There's so many. Actually, you could put a little star in your notes. 75% of the answers in environmental science are going to be positive feedback loops. The idea is, can I describe one? Because that's what you're going to have to do. For this test, it's let's understand the difference, and then we'll go over examples throughout the whole year. Negative, the change will cause a change in the opposite direction. So a great one is like your thermostat at home. If I put the air at 75, my house is going to cool. If I put the air at 70, my house is going to cool. We're in Florida. Once it gets to 70, what happens to the temperature in the house? Or what happens to the AC? It turns off. And then the house starts to get a little bit warmer until it's about to go over, and then it causes it to turn back on. Negative feedback loop. Okay? Same thing with internal systems. A lot of them are described as negative feedback loops. All right, so 96% of the human body is made up of what? This you learn in body. I mean in bio.
Atoms.
What? I'm referencing elements. What elements? Carbon is one of them. Water, which is made up of what? Hydrogen and oxygen. Is it starting to ring a bell?
Nitrogen.
Yes.
Phosphorus.
Yes.
Sulfur.
Sulfur. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So CHOMPS or CHON-PS. Or carbon, hydrogen, oxygen, cycling through all the layers of Earth and all living things, or parts of Earth and the living things. When water travels through the Earth or cycles through Earth, it's called the hydrologic cycle, and it actually will travel through every single layer and every living thing, right? Because 70% of you is water, 70% of Earth is water. As I mentioned before, no starting point. It's a cycle, or it's a chain, or it's whatever you want to call it. I have to pick a starting point. That might not be the starting point on the test. It won't be, okay? It'll be different. I'm starting in the atmosphere. So my first question is, how does water go anywhere on Earth into the atmosphere? What's that process called? Evaporation. Where does it evaporate from? From where in the biosphere, let's say? Lakes. Oceans, yes. And it's going from a liquid state to a gas state. But when it evaporates from a living thing, specifically a tree, anybody know what that's called? Tree. Or leaves of trees, I should say. Transpiration. Evaporation from the leaves of trees. Same thing, it's from liquid to gas, but it's coming from a living thing. So water will leave lakes, puddles, rivers, and evaporate into our atmosphere. And once it's there, what's going to happen to it?
Precipitation.
Before precipitation, I'll give you that.
Condenses.
It condenses. So it's going to go from its gas state back to liquid state. And then it's going to fall, which is precipitation, in the form of rain, snow, hail, and sleet. Good job. All right, precipitation, if rain, hail, snow falls, where does it land? It could land on the ground, or it could land back into a body of water. We're going to focus on the land, right? Because we know if it falls in the water, it's going to evaporate. If it falls on land, I'm going to start here, and it goes straight back into a large body of water, like an ocean, we call this runoff. We call this surface runoff. Runoff is when water flows to a large body of water. So water that falls on land can go across the surface and go straight into a lake or an ocean. Yes? Because have you ever put a drop of water on a table and it looks for the rest of the waters, right? They all come together. Water wants to do that. But if it falls on land and it goes through the soil into the ground, we call that infiltration. When it percolates, it's going to go through what? Once you're in the land, what's below? Which kind of filters the water. So we went through the soil, through infiltration, and then we found a lot of what? Rocks. Good. And then, I left this word out, we're going to land in our underground rivers. What do we call those? Aquifers. But the aquifers will pour into the ocean through runoff. So once you land in our underground rivers, we're going to run off back into a large body of water. It will infiltrate into the ground or through the soil, percolate through the rocks, and land in an underground body of water called an aquifer. That aquifer flows back into an ocean or a river, because an aquifer is an underground river.